Hi, I'm Ray. I'm one of the squares. I've never said anything in less than 5 minutes, so I'm going to do my best here. But like I said, I'm not actually timing it. I'm here to talk to you about how we manage the intersection of the Android's UI thread and all of the interesting threading games that RxJava likes to play. Since time is short, I'm not actually going to tell you anything about what RxJava is or how to use it. I'm going to assume either you know or you're going to go look it up. But before I talk about that at all, I want to stipulate one kind of given condition, which is fixing problems in the way that you see on the screen, where I'm not sure why this isn't working, but it seems to work once I call post. Okay, I guess that's fine. Doesn't really work. More appropriate name for that method is actually install landmine, because the odds are the way it's going to present itself to you is as a null pointer exception or some other kind of mysterious low frequency but high frequency enough problem as time goes by. Pretty much, you do a post, you're creating a race condition, and once you deploy, every race will be run. Once you're at the scale of having millions of downloads, then you're in a situation where every code path and every corner case are going to be hit by somebody at some point every day, dozens or hundreds or thousands of times. And each time you do one of these, post types of situations, you're adding another dimension to the combinatorial explosion. So the lesson that we've learned over and over again and remind each other of, particularly if Pierre is on the code review, is to keep your main thread synchronous. Now, that's easy to say and it's nice to mouth, but it's also kind of in conflict with the fact that any kind of a client-server situation, any mobile app, any web app, has to live with the fact that the net is inherently asynchronous. My data lives someplace else, and it's going to get to me eventually, and I've got to be ready to receive it when it gets there. But at the same time, if I have my data right now, I'd like to be able to use it now, and ideally I've got one code path to do that kind of thing. That's why we're all been so excited about using RxJava. It kind of solves a lot of those problems, or at least gives us ways to express that kind of thing. So imagine you have a company that, say, delivers food to people on demand, and you've got an app that needs to have a live display kept up to date of what restaurants are open, what's the delivery time at the moment, what's the wait time, has the rating changed, that kind of a thing. You've probably all learned by now that you can use a framework like Picasso to get easy, no-brain access to your image resources. So if it's in my RAM cache already, shows up in the view right away. If I have to wait for it a little bit, it'll push it into me sooner or later, and life is good. We've been using Rx to do the same kind of things with our models, how we keep track of the information that we have that we're ready to display, that maybe eventually asynchronously we'll need to pull from disk or pull from the cloud, kind of the same sort of pattern. The way that winds up looking in code, and this is more of an eye chart than I expected, sorry about that. Well, actually, let's hit Command- on that first, so we can hide some of the Java boilerplate and give ourselves the nice kind of reduced view that Studio provides for us. We've got a restaurants model object. We're going to ask it for a particular observable for a particular restaurant. We're going to observe that on Android's main thread, and we're going to subscribe so that every time we learn that there's a change to the restaurant, or as soon as the first time we get that information, we're just going to plow that information into our view. Life is good, or it's good-ish. If you look at that second line that you can't possibly read from any of these seats, our observe on line, observe on Android schedulers.main thread, is a bit of a trap. Because if we drill into the source code there, what we find at the very heart of it is this.handler post delayed, and we're back with our post situation. And once again, our initial display, or any time we want to display any kind of information in our UI bound this way, we're getting it after an asynchronous post. There's some flicker that's going to go on, and there's no kind of deterministic path for showing the data that happens on our first run of the app. So now your first reaction to that might be, no problem, I can fix that. I can make the scheduler smarter. I can see what thread I'm on and just be synchronous when appropriate. And actually, no, you can't. We've tried, I tried, and Rx. And if I talked longer, I could probably explain why it's a problem and how you lose exceptions occasionally and so on. But it turns out it's not really a problem that's worth solving. All that we're concerned about here is the threadedness of how information is getting from our model object into our UI. We don't want there to be a post there. We want that to be synchronous when it can be. But we're in control. We're the boss here, and there's no reason that we can't just move that problematic boundary onto the other side of the model. As long as we give ourselves a simple rule of making sure that updates to the model are initiated from the main thread, everything downstream of there is also going to be happily on the main thread. Nothing bad's going to happen because Rx is single-threaded by default. Even though it lets you start to play games with, oh, I want this thread to make the request and this thread to receive the response. If you don't do that, it's not going to go jumping threads on you, and life will be simple and grand. So what that looks like in your code is, don't do that. You're not being a good developer by being extra explicit, saying, no, seriously, it's got to be on the main thread. You're actually causing yourself side effects, and you're going to forget to write that half the time anyway, so we might as well make sure that it works. And over in model land, I'm probably over time. We'll just skim through the R charts really quickly. But in the call that we first looked at, where we're grabbing a restaurant out of the restaurants, we're still not worrying about threadedness because farther upstream, we promised ourselves that this would only happen on the main thread. We'll just give ourselves a little map on a little behavior subject. It's our list of restaurants. Pull out the one that actually matches the given ID, and now the UI has a nice, lively object that's going to ping it every time there's something interesting to say about the restaurant. And on the update side, we can either make it safe to call ourselves from every thread. We can do some trampoline games to make sure that regardless of what thread is pushing the data into ourselves, we'll do some extra switching and post it into the main thread. Or we can decide that that's a lot of work and that's a lot of extra object instantiation, and we can instead just throw an exception if anybody is rude enough to try to call our model object from a thread other than main, blow up the app, and fix the place where that happened. It's not such a burden, and it keeps the UI code still blissfully ignorant that all of these games are going on. So basically, you can keep your main thread synchronous and understand what's going on. You can deal with the asynchronous nature of life like you have to, and you can pick both of those things. You don't have to trade them off. How'd I do on time? Was anybody clocking it?